So for the agency list, we did the agency list ourselves manually, and we put the result in the main function. As you can see in the example, we did the agency list for appendix A and just put it in the code.
Good morning, doctor and everyone. My name is Chen Chun Hao. My tree number 300310. Today, I will continue presenting about brief first search or BFS. This is a way to explore a graph step by step. It starts at one point, visit it, then add all nearby points into a queue. From there, it visits each one in order and keep adding their neighbors if they have not been visited yet. It keeps going until there's nothing left in the queue. In our code, we use a queue to track what next and a set of avoid repeats. The output shows the visit order, number of point research, and how long it took to finish.
Assalamualaikum and good morning. My name is Muhammad Dani Hakim and my metric number is 297822. So I will continue the presentation, which is DFS recursive part. So definition for DFS is a fundamental algorithm used for traversing or searching through graph data structures. The recursive version of DFS is a method of implementing this algorithm using recursion, which allows the function to call itself to explore deeper into the graph. So for our group project, we use DFS, goes deep, it start at one node, then visit the next neighbor, then the next, going as far as possible before backing up. We use recursion to do this, and the program call itself again and again until there are no more unvisited neighbors.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zuhaf Bizim Zakaria. My number matrix is 298 and 230. So I will be presenting about the DFS iterative. So what is the DFS iterative? DFS iterative is a method of the non-recursive. So um, the DFS iterative, the DFS is a method that is version of the depth first search that uses the explicit state to explore the node in the graphs. So instead of relying the system call state like the recursive approach, this method manually manage the state and which is give more control and avoid the issue like overflow in the large graphs. So traverser begin by pushing the starting node onto the track. So onto the stack. So where the stack is not empty, it is pop the top node, and if the node has been visited, it marked as visited and recorded in the traversal order. To maintain the correct depth first behavior, the neighbor of the current node are accessed to the adjacent list. So they ensure the leftmost or lowest index neighbor is visited first and mimicking the recursive pattern. Overall, the FS iterative is a memory efficient and safe way to perform the depth first traversal, especially useful when dealing with the deep and large graphs. So as you can see on the right side of the slide, it is the coding that I created. So in the so the title of the this coding is DFS traversal. So I'll be using the integer. So it will start with set integer visited the new hash set. So and the stat also the integer stat with new stat list integer traversal order and new array list. I insert the array list for the for 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 storing the nodes given. So the the start time, I'm using the system nano time to measure the performance. So to simulate the behavior of the recursive DFS and ensure the consistent of visiting order, the algorithm retrieve the current nodes neighbor and push them into the stack in reverse order using the list iterator, this will be ensured the leftmost or will set that or the smallest index neighbor are visited first, mimicking the recursive approach. So once all nodes are reachable from the starting node, from the starting node have been visited, the algorithm will stop the timer and prints all the result, including the traversal order. So we can see the SOP here. It will be print out all the traversal order and the also the node visited and number of the edge, and lastly the time, start time and the end time. So that's all from me. Thank you.
Greetings and hi everyone. First thing first, let me introduce myself. My name is Carlos Anakion. My phone number 297-503. So for now, I will present the final part of our project, that is the output and the analysis. So I have got some simple diagram here. So first we tested our programs on the three graph labels A, B, and C. So for this graph, we're loaded using agency list, and we applied all three traversal methods, BFS, DFS recursive, and DFS iterative for each one. So for the output from each test includes four important pieces of information. Just four. So first is the order in which the nodes were visited, and the second is the total number of nodes visited. Third, the number of edges used in the traversal, and four, the execution time measured in nanoseconds. So now we move to the analysis. So based on the output that we conclude, so DFS, both recursive and iterative, was generally faster than BFS itself. This is because BFS uses a queue, which adds some overhead, while DFS, especially the iterative version, is more lightweight. However, BFS is more suitable when we need to find a shorter path, as it excludes level by level. The recursive DF, uh, the recursive DFS was easy to write, but it can crash on very deep graph due to stack overflow. On the other hand, iterative DFS avoid that issue because it uses a custom stack. So for the conclusion, for performance, DFS absolutely wins, especially iterative DFS. But for shorter path problem or where level order is important, BFS is the better choice. So that's all from me. Thank you.